Hi, this is a little video just showing you the answers to the very first homework that I think you're going to be receiving. It's a Surds and Indices homework. I think it's pretty much the very first one you do. Okay, so let's have a look at some of these. Now, I'm just going to quickly mention that before I do this, the surds are slightly different, but for the powers, I'm really just going to be using mostly these two rules. Add in that case, and for this one, we're going to times. I hope you understand why we do these things as well, because it's pretty easy to see why those rules need to hold. Firstly, just what do powers mean? If I've got x squared times x cubed, well, really, I've got x times x. This just counts how many x's are there, and then x times x times x. Well, that counts how many x's are there. And so clearly, I'm going to need to add these powers to realize that that is x to the power of 5. That's the reason why we add the powers. Now, why do we times them in the other situation? Well, if you've got x squared cubed, you've really got x squared times x squared times x squared. And so here, you've got repeated addition, and repeated addition is multiplication. And that's why we need to do the 2 times 3, which is x to the power of 6, because we're doing 2 plus 2 plus 2 3 times. So that's the reason why the rules work. And really, that's all you need for a lot of this homework. You also need some surds understanding as well. We'll mention that in a second. But anyway, let's try and use these ideas. So what have we got first? Let's zoom in a little bit. We've got 2x to the 2/3 times by 3x to the minus 1. Now remember, multiplication is something called it's commutative. And all that means is you can do it in any order you like, which is why what we can do here is we can deal with the x to the 2/3 times x to the minus 1 and the 2 times 3 separately. So we're going to get 2 times 3, which is 6, and then x to the 2/3 times x to the power of minus 1. We just have to add the powers, and 2/3 plus -1 is minus 1/3. And really, that's all there is to it. It's the same with these kind of ones. If you first write this as x to the power of a third, because cube root is power of a third, and then we're going to do that to the power of 6, well, we need to times these powers together, and that's going to give us x squared. Here, now be careful here, 2 needs to be put to the power of 5, and 2 to the power of 5 is 32, and then you need to do x to the power of 4 to the power of 5, and so we're going to times those powers together, I'm going to get 32x to the power of 20. If you want to know why we're doing that, it's because it's 2x to the 4 times 2x to the 4 times 2x to the 4 dot 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 5 times, and that's why it's going to be 2 times 2 times 2 times 2, which is 32, and x to the 4 times x to the 4 times x to the 4, etc. 5 times, so that's x to the 20. Okay, here, what I'd probably do first is think, well, 10 cubed is 1,000, times by 3 is 3,000, just simplifying the top. Y to the 4 times y cubed is y to the 7. You don't have to do it in the same order as me, you can still get the same answer. Over 2y to the 5. So I think that's 1,500y squared. And then here, okay, here's another thing which I might want to mention with this homework. If you're ever doing something to the power of 2/3, what does it really mean if you've got a number to the power of 2/3? Well, it means 64 to the power of a third squared. Power of a third means cube root, and the reason why that's the case is because we times that, and 2 times a third is 2/3. But power of a third is cube root, and the cube root of 64 is 4. So we're really doing 4 squared, and so that's 16. So what we're going to have here is 16 x to the power of, now do 2/3 times 18, and 2/3 of 18 is 12, because 1/3 is 6. Okay, right, let's go to the next row. This will be a little bit easier in some ways, provided you remember what your power rules are, which is x to the, well, let's do it with x, because we're going to do it with 11 in a second. X to the power of minus 1 is 1 over x. X to the power of minus 2 is 2 over x. I might want to justify, 2 over x, 1 over x squared, and so on and so forth. I'm going to quickly justify this, because I like showing people why these things work, Have a look at it like this. 7 to the power of 4 is 7 times 7 times 7 times 7. I don't think there's too much controversy there. 7 cubed is 7 times 7 times 7. I'm just working with sevens. I picked that number arbitrarily. I just thought I'd working with sevens. Okay, and then 7 to the power of 1 is 7. Well, if we're going to continue this pattern, we're dividing by 7 each time. Yeah, we like patterns in that, so we can continue the pattern. And so if you did this divided by 7, you'd end up with 7 to the power of 0. Now, 7 divided by 7 is 1. That's the reason why anything to the power of 0 is 1. It just makes sense like that to continue the pattern. It also ensures that x to the a over x to the b, which equals x to the a minus b, if we want that rule to always work, well, anything divided by itself is 1. So when a equals b, you need to have this side equaling, this side obviously equals 1 because you've got something divided by itself that equals 1. But if a equals b, this ends up being 0. So x to the power of 0 must be 1. Now let's just continue this pattern. We divide by 7 again. And what is that divided by 7? Well, it's 1 over 7. And we divide by 7 again. Well, what is that divided by 7? It's 1 over 7 times 7. It's 1 over 7 squared. Because if you divide a 7 by 7, you get 1 over 7 times 7, or 1 over 7 times 7 like that, just to avoid the ambiguity. And that's 1 over 7 squared, and so on and so forth. So that's the reason why 11 to the minus 2 needs to be 1 over 11 squared. Please simplify that though, 1 over 121. Here we've got square root of 100, which is 10, cubed, which is 1,000. Here we've got, now you can do this in any order. You can do cube root of 27, 3. Square it, you get 9. The negative puts a 1 over it, so that's 1/9. Anything to the power of 0 is 1. And this is, well, if you write this as 2 to the power of 5 first, it's arguably slightly easier to simplify, because then we can just times those powers together, giving us 2 to the power of 4, and add the powers, you're going to get 2 cubed. There's other ways of doing that, though. You could have worked this out as a half, and this out as 16, and a half times 16 is 8. Yeah, so there's lots of ways of thinking about it. Now we're going to write these as powers. Well, this is 3 to the minus 2. We want these all to the power of 3. This is 3 to the power of a third. This is going to be 3 cubed, I'm going to do this in 2 steps, times 3 to the half, because square root means a half. Add the powers, you're going to get 3 to the 3.5 if you're a lover of decimals, but if you prefer fractions, and I certainly do, you write it as 7 over 2. Here, write the 9 as 3 squared first, so you realise that's 3 squared to the power of 15, which is 3 to the power of 30. So we've got 3 to the 10 times 3 to the 30, and that's 3 to the 40. This is going to be 1 over 3 to the power of 4. Yeah, so always look for the power of 3 in there. Then you can write that as 1 over 3 to the power of 4 to the power of a third. And so that's 3 to the 4 thirds, which is 3 to the minus. That one took a little while, but we got there in the end. Okay, what about question 4? Okay, anything to the power of 0 is 1. So that's one of those ones you just got to try and spot, really. Here, to get rid of to the power of a third, it's probably easier to think of it as cube root of x is 2, and therefore x is going to be 8. So you need to do the opposite here to what you might think. Sometimes people think, oh, I need to cube root of 2. No, you need to cube root to cube 2 to undo the cube root of 2. Here, we've got x to the minus 4 is 81. So x to the 4, just reciprocate, is 1 over 81. You can do this in different orders, actually. And so x is going to be 1/3. Maybe you prefer to do, fourth root here and get 3 here, and then do the minus 1, so your x is a third. You can check your answer as well. A third to the power of minus 2 is 9, and 9 squared is 81. Does that make sense? Here, by sight, x to the minus 1 will work, because that's 1/10. And here, well, the square root of 25 is 5. The square root of x squared is x. So 5x equals 15. And so x is 3. Okay, right. On to number 5. We're burning from this. This is good. Okay, right. Well, if you've ever got 7 to the power of this is 7 to the power of that, well, then you can always argue that this equals that. Rearranging this in my head, I can see I'm going to get 3x equals 7. And so x is 7/3. X is thirds. Happy with that? Hopefully you're happy with that. Now, B is where it starts getting interesting. I might give myself some more space for this because these are a little bit tougher. If you ever see an equation you've got to solve with powers where you can't identify the link between 27 and 81, look for a power which they share in common. So 27 is 3 cubed to the power of x plus 2, and 81 is 3 to the power of 4 to the power of 3 minus 2x. So you want to know your powers. And then you're going to multiply there because it's a situation of x to the a to the b. And so what have we got here? We've got 3x plus 6, because we're going to times 2 by 3 as well, equals 12 minus 8x. And so we get 11x is 6. So x is 6/11. That's a bit harder. Take away the 6 from both sides, add the 8x over. C is a similar one, because you can call it 2 cubed to the power of 1 minus x. Put the 1 minus x in brackets if you like to remind yourself. Everything needs to be times by 3 there. That's 2 to the minus 2. We're putting that to the power of 3x minus 5. And so we get 3 minus 3x is minus 6x plus 10. And therefore we get 3x on this side if we add 6x, and 7 on that side if we take away 3. We've got x is 7/3 again. I'm sure that came up somewhere else in this homework. They're tricky though, those ones. They're a little bit trickier. Okay, D, x to the minus 4/3 is 16. Well, this is similar to an earlier one we did, because we can say, okay, x to the 4/3 then is 1/16. And then, now I need to do the opposite here. Essentially what we're doing is x to the 4/3 to the 3/4, because 4/3 times 3/4 is x to the power of 1, which is what I'm looking for. So I need to do 1/16 to the power of 3/4, but it's really easy to think there that you're doing 4/3, x 1/16 to the 4/3. You're not, you're doing the opposite, the reciprocal of the power. And so you get x to the power of 1 equals, now the 4th root of 16 would be 2, and then you just need to cube it, so x equals 1/8. Okay, E. Well, this is x to the 3rd equals 2x to the half. Let's divide that x to the half over. Now, if you've got x to the 3rd divided by x to the half, you're going to subtract those powers. And a 3rd minus a half is like 2/6 minus 3/6. So that's minus a 6th. And so x to the power of a 6th equals 1/2. And now I need to do power of 6 to both sides, because that will undo my 1/6. If you like, the 6th root of x is a half, and so I need to do a half to the power of 6. 2 to the power of 6 is 64, so I'm going to get 1/64 for x then. Okay, this is definitely looking like a tough one, f. So let's see what we got. This looks like it might take a little while. Square everything, you're going to get x to the 4 times by x over, I suppose we're going to square root the other side, but I don't fancy it. And then, now think of this as x to the 3/4, because that's indeed what it is, because you're doing cube and then 4th root. And so it's x cubed to the power of a quarter, and that's x to the power of 3/4. Now, if we now apply the rule that you times the power there, you're going to get x to the 3/4 times 2, which is x to the 3/2. There's a lot of work there. Write that again so it's a bit clearer what I'm doing. Cool. And that equals 1/128. I'm going to write that as 2 to the minus 7, actually, because I'm pretty sure that's 2 to the minus 7. It might help me later on. I don't know. You don't have to. Okay, the top is x to the 5. The bottom is x to the 3/2. And we're going to subtract those powers. Maybe I'll leave it as 1/128. Maybe I'll stress you out. So that's 5 minus 3/2 is 3.5, which is 7/2. this is why I'd like to write it as 2 to the minus 7 in some ways. But yeah, it doesn't matter. And now, therefore, I'm going to do power of 2/7 both sides to undo the 7 over 2. Now, if we seventh root that, we get a half. Square it, we get a quarter. So x is a quarter. Okay, these surd ones aren't too bad, actually, because they're just simplifying surds. Let's give ourselves some space to work. Oh, actually, we shouldn't need to. Biggest square factor. Biggest square factor there is 36, I reckon. And so you're going to get 6 root 2. Here, lots of different ways of doing this. They want it in the form of a root b. We could write it as 3 root 20, because when you've got root a times root b, that equals root ab. But root 20 is actually 2 root 5. And so here's another way of looking at it. This is like root 5 times root 2. That's root 10 times by another root 2. And if you do root 2 times root 2, it's just 2. So that's 6 root 5. If you had 3 root 20, you're sort of half right, but you haven't completely simplified it. Here, that's like 5 times 100, so a big square factor would be 100. So that's going to be 10 root 5. Square root of 125, well, that's like 25 times 5, so you can square root of 25, giving you 5 root 5. And then 10 root 5 plus 5 root 5 is 15 root 5. Just like 10 cats plus 5 cats is 15 cats. Okay, if we write this as 2 root 2, essentially, you're going to have 5 times 2 root 2, which is 10 root 2, minus 3 root 2, which is 7 root 2. Done. Okay, only a couple more to go. Fair play if you've skipped to the questions you're worried about. I would have done the same. Okay, if we times top and bottom by root 2 here, we're going to rationalize the denominator. Now that's going to leave us with 12 over 2, which is, yeah, that's right, it's 12 root 2 over 2. But that's just 6 root 2. You can simplify that to 6 root 2. Because just like 12x divided by 2 is 6x, 12 root 2 divided by 2 is 6 root 2. This one, if we times top and bottom by root 5, we're going to have 5 times 3, 15, so you're going to have 10 root 5 over 15. But look, we can simplify that to 2 root 5 over 3. There's a little simplification that can be made. Here, best thing to do would probably be to times by 4 plus root 3 over 4 plus root 3. Now, just over here, let's do a little 4 minus root 3, 4 plus root 3. The reason why we're doing this is because with surds, it always gets rid of any square roots. Because you're going to get 16 minus 4 root 3 plus 4 root 3. The surds will always cancel. But then root 3 times minus root 3 makes minus 3. Yeah? And in general, root x times root x is always x. There's lots of good reasons for that. You can think of it as x to the power of a half times x to the power of a half. Add the powers, you get x to the power of 1. Or you can think of it as it's root x squared times it by itself, and if you square it with square, obviously you're getting back to the back to where you started. And so yeah, root 3 times minus root 3 is just minus 3. That's 16 minus 3, which is 13. So what are we going to have over here? We're going to have 26 times 4, which is 104, plus 26 times root 3, which is 26 root 3. But then we're dividing this by 13, yeah? Now, as this is 26 times 4, it's also 13 times 8. And so that's divisible by 13, and it goes 8 times. Whereas this will be divisible twice, and so it's 8 plus 2 root 13, I think. This one, we're going to times it by 3 minus root 5 over 3 minus root 5. Now, what's that going to give us? Well, similar to the last one, we're going to get 9 minus 5 on the bottom, which is 4. And then we're going to get, now on the top, it doesn't hurt to draw out these grids if you're a bit confused. I used to do them definitely when I was younger all the time. 3 minus root 5, you're going to get 3 minus 3 root 5 minus root 5, and then you're going to get plus 5. So you're going to end up with 8 minus 4 root 5. And look at that, they're both divisible by 4. So do simplify it to 2 minus root 5. Remember, all these answers you could check on the calculator, but it's definitely well worth being able to do this without a calc. Not everything is about a calculator. You might think, oh, I've got it in the exam, but it slows you down. It really does. Okay, here that's 25 times 2, so that's 5 root 2 if I square root the 25. This one, if I times top and bottom by root 3, I get 6 root 3 over 3, which is 2 root 3. So the answer is 5 root 2 plus 2 root 3. Okay, hopefully I got through that without making any mistakes. Let's have a quick look at the answer sheet. Looks about right. I don't remember getting 3 to the 40 on question 3D. Did I get 3 to the 40 on question 3D? I hope so. I can barely remember. 3 to the 40. It's normal as well to make little errors. Yeah, all maths teachers do it. Looks like I've got it right here. But all maths teachers do it, all mathematicians do it. We all make little mistakes. If I've made a little mistake here, feel free to let me know in the comments and I'll correct it. Cool. Well done, everybody. Best of luck on the next homework and keep up the hard work. Bye-bye.